Yeah, so the last class I said we talked about the line plot. The line plot, we talked about the scattered plots and also the histogram. This was the three major one we draw much on. Though we also have some other type, but we dwelled much on the three major ones. There's also we talked about the bar chart also. Yeah, the bar chart. So let's go into the tax. Okay, I think this is for the solution. So, okay, I think the first one now, the first part of the tax, this I just added some things there where you just put your name and the date you submitted it. But this is actually the data set we are using. Hope you cannot see it. This is it here. So it contains the region and this random seed now is just because when we are working upon it, we want it to be reproducible. So we give a value to it because there's a way you can generate some random numbers. When we want to generate random numbers, now there is this NumPy.random. When you generate a random number and you want to run that same code again, if you assume you are generating a random number, you will get another number because what the stuff is random. Hope you are with me.
Yeah.
So now you giving it this random seed of 42 random seed. Now we'll read about it. It tells us how that number will help us to predict how predictable the stuff is. We can use random number and generate the same number each and every time we run the code, or generate the data set that will be very close to themselves. That is possible by what? The seed, the numbers in here. So let's see if we can read the information they said here. Okay, random number generation. It uses default run to create a generator and call it method. So that number is just for us to be able to produce numbers that will be consistent. So that is just what that number is. So now the reason why is the region here, we have random choice. We are using random here, north, south, east, and west. And we want to create 80 data sets. I don't know, 80, yeah, 80 data in our data set. But here we just gave it what? Some values, north, south, east, west. So it will pick a random choice from this and fill it up that table up to 80. Hope you agree with me.
Yeah.
Hello. Yeah,
I did
so
not get that part very well. So
is it the random choice or which one? The random seed?
the previous this recent explanation, I'm
Yeah.
lost along the track.
Okay, I said when we are using random means we generating random numbers or picking something that's random. Let's say I have 4 balls now, blue, red, yellow, green, and I want to pick one of them as random. The first time I will pick it, I can pick red. The second time I want to pick again, let's return all the balls together, I can pick yellow. The third time I have to pick it again, let's return it together, I'll pick another thing. Now, when we are now applying it to a code now, assuming you are choosing a random number, I run a code from here, you are running it, you believe because we are using random, we'll be generating different type of data sets because we are using what? Random. If you are with me, just let me know by terms of thank you. So now when we are now using that seed is to help us determine how reproducible that number is. There is a way I can make it that even though I'm picking a number as random, the first time I will pick a ball, maybe I'm picking red. Even for the next 5 times I'll be picking the ball. So it's possible I can be picking red, red, red. It's possible. And I pick the second one, maybe yellow. And maybe so that is that number, what's that 42 in front of the seed is doing. It helps us predict how predictable is that random number will be picked. How can we reproduce it? So we can set it very high or very low. The chances, yeah, just like probability, the
Okay, that
chances
means
of me,
the chances of we picking the same thing is
yeah,
42
yeah,
times. Okay.
yeah, thank you. So that is exactly what that part does. So now And this n is 80. That means we want to create a data set. The same way we have the rows. We want to create a data that will have 8 rows. You know what a rows and a colon is? The rows is the vertical and the horizontal, yeah. Row 1, row 2, row 3, like that. And the colon 1, colon 2, and like that. So now these are columns: region, product, revenue, unit sold, month, and rating. So we want to fill this each column with 80 items, 80 individual data. So now you can see in this region we are just having 4 values here, and we want to use it to fill 80 data sets. This n is what 80 here. So how do we do that? Out of these 4 stuff, we want to pick a random. The first time maybe we'll pick north, the second time we'll pick south, the third one is north. We'll fill it just randomly, the random choice. So that's why you are saying we are picking randomly, but now you are not generating a random number, you are just generating picking something that has choice, options. Same thing with product, we will just pick all these up randomly. Same thing with our number revenue, we will generate numbers between 500 and what 5,000, and we will generate random integers. Integer means whole number. Same thing with units sold, between 1 and what and 50. So same thing with also units sold and months, rather 1 to 13. This place is meant to be 12, but let's leave it. That is an error. I can change it, but let me leave it like that, like January, February, like that. So it's meant to be 1 to 12. And the rating, random, uniform, and all that. So we generate them randomly. So to make sure our stuff is reproducible, that's why we have to pick a number like this. So the first part of the question says we'll be using Matplotlib. I decided just to focus on Matplotlib here because we didn't really use Seaborn. We'll be creating a multi-panel figure. That is, we have a 2 figure. We create a single figure that we have 2 subplots side by side. The first one will be what? Bar charts.
No, sir. Please,
yes.
Can you make your screen full screen? It's
Full screen.
Full. Is it from my end?
It's from your end. You see an option to select.
Okay. Sorry, I've done that.
Have you seen it?
Yes.
Yeah.
Thank you.
So now, the left side will have a bar chart. What is the bar chart? This is the bar chart. This is the bar chart, as you can see here. And the right side we have a line plot. So we want to create 2 pictures, 2 figures in one diagram. So that's what we mean by the side by side. So, and some things has already been given. So we will add a descriptive title. That is, we will add a title to the figure, and we will save that figure as what? A1 revenue overview PNG. You will save it. So the axis has been given and the figure size. The title has also been given, revenue overview, the font size, and also what? The font weight. Both. You can change this one as you want, or you can even remove this font weight side. It will automatically select default. So now this is where our main code will be. For the left plot, what will be in the left side, we are plotting what? A bar chart. What will be in the right side, we are plotting what? A line chart. So after that, we will then plot our figure. Then we'll save it as is. Then we'll show this plot dot show. If you didn't put it there, the plot won't be displayed. It won't be displayed. So that is just for the A1, the tax A1 now. Let me try and see last week part, where we worked on bar charts. Now, is bar chart. So we have a product and sales. So when we wanted to plot the bar chart, this one is a variable name. You can give it anything you want. We had to use what? Plot.bar. Then what are the values we want to plot? Product against what? Sales. So that is product against sales, just like in mathematics, x against y. These are our x-axis and these are our y-axis. So product against sales. Then we have to pick different colors. This one I can decide to leave it at default. It will select the same color for all of them. But because I want to differentiate them, that's why we gave it different color. This one is not compulsory. What is compulsory is this part, plus dot bar, then this. So now, because it's a bar chart, you need to, it's like we had a loop here for each of the bars in this, because we have like 4 different values here, 4 different products. For each bars in bar, then the y value, it will get the height, then it will plot it, it will get the width also, because we are creating the information that it needs to plot this graph, the width, how do we want it to be, and all that. So it will get the width and we divide it by 2. These are just to define how your bars will be like. Then the major part now is the X label. Here we are labeling the X axis, which is product. So you can see product here. This is where the label is product. The Y axis, sales. You can see it. This is a label. And the title, product sales comparison. You can see it here. Then we have to put this one there to show our what? Our bar chart. Hope you can see it. So now let's now apply it in our left hand side there. What are we asked to plot? Bar chart of what? Total revenue per what? Per region. The total revenue is what? The revenue of this place per what? Per region. So that means after we've gotten our data set, we still need to do some data analysis on our data set. We need to, because each region we have not, we might have not occurring in like 40 places out of the 80. We need to calculate the total revenue of all the places that are, all the regions that are not. So we need to do that data analysis first before we can now plot our graph, our bar charts rather. So after we've done that, what else are we going to do? That is just for this. And we'll have different colors label at the top. Because now, because revenue per region. So what are we going, how many bars are we going to have in the plot? Just 4. Because we have the how many region? 4 region. Victoria, are you still with me?
Yes, I'm here.
If you are not getting it at any point, you can let me know. So we have those 4 regions: north, south, east, and west. So we'll be having those 4 bars. So now we can, it's different because it's just 4, we can give it different colors we want. And the values will be labeled on top. It will be labeled on top, maybe these values, these 450 and like that. Example is here. I'm coming. You can see this value. Now this one is horizontal. Normally bar chart is meant to be straight like this, but this one is horizontal. So you can see the values. So that is why we can see vertical and what horizontal. So vertical is when you are comparing values, while horizontal is long categories label that need space. So, but it's not what we are explaining is now is looking simple, but it's not actually writing the codes that becomes more tedious a little bit. So now we can see now revenue by region data frame. But before this, I said we need to do some data analysis. I created, okay, this is my information. Now how to print, I don't want to generate this part again because you know we said it's a random seed. I don't know if it should still give me the same data, but it should. Let me create a new code tab here since I've already run it. I want to print this my data frame. So I'll just do df.head. I believe you all know what that is. df.head. So that will show us the top 5. So after I run that, I also run df info to get some things. So you can see region now, east, west, north, east. It's just picking it randomly. And it's picking the product to everything there, random. Unit sold, month, rating. Can you see everything was done randomly? So let me add another one. df.info. Let me see what this one. And I still have another one. One we do describe. So that one will give us something else. Yeah, this means we didn't have any missing columns in our work. We have 80 entries and we're having 80 non-empty entries. So there is no issue. So let's check describe. These are some things, especially if you're into data analysis, these are some things you'll be familiar with. So this describes the mean of all our data for the revenue, the count, the mean of the revenue, units sold, and some other things. So now, this was already given. We have to put our code here. So we have revenue by region. We need to group our revenue. So that is why we apply this group by. So because we have region, so we are picking the region column from our data. The region column, we are picking this. Then what are we picking in the region? We are picking the revenue. So we are grouping the revenue by what? By region. Hope you are getting it. So then after this has been explained, then this dot sum means we are doing what? We are finding the sum of the revenue by region. So calculate the sum of the revenue by region. So if I should do this, this will give me the sum of the what? Of the revenue. But now applying this dot sort values means you want to do the arrangement, maybe ascending or descending. Now this one, ascending is first. That means this is arranged by what? Descending order. Let me try and run this. Let me copy this. Can you see? I think it's even showing this stuff for us. So now revenue by region. I want you to bring the graph. So it's only have 4. Can you see it here? The first one, 45. One is around 1, like that. So once we run it, it will find the sum and it will group it. Then this one is sort values. So it means from descending, the highest to the what? To the lowest. But if it's from ascending means from the lowest to the what? To the highest. And we put ascending to be what? To be first. So this one is just to sort our values. This one is not compulsory. We don't need it. It's not compulsory, but if you want, you can add it. But the compulsory one is this group by and what? And sum. And you can decide to write all these ones little by little. Revenue by region. Put this, then you put lose sum later and the rest. So now this one is to add colors. So this one is to get color map. This one we are trying to do it automatically. We don't want to start defining colors. Oh, this one pick this color, this one pick this color. This one we are mapping a color to them. And also for our axis, we are not defining it. For the axis 0, okay, and the axis each bar. For the first one, we are giving this for revenue by region. The index of it is 0. That is the first one. So it will find the revenue by region values. Then the color now, it will pick a color from here. Because we are picking the color automatic. We are not defining the color individually here. But you can decide to do your own by yourself. It's your choice. All these ones are just compressing this because this was suggested by Gemini. That is why a lot of complexity are there. But you can decide to simplify it. If I want to simplify this, I'll simplify it and still get the same results. Maybe I should even do that in another line. So now we have all this one. These are the major important parts. Set axis, set title, total region. The reason why we're having axis 0 here because we have 2 plots. Axis 0 is for plot 1, and axis 1 is for what? Plot, and the second right plot. Hope you are getting it. That's why we are seeing axis here. So we are using that one to differentiate the 2 plots. Let me show you the plots. We are using it to differentiate the 2 plots. This axis 0, this is axis 1. So that is why we are seeing axis 0 dot this and that. So it's just like what we have here. I'm coming. You can see bar, the set title, the title that will be on top of the first graph, the label region, that is for X, the label for Y, total revenue. Then for I in this, just like what we have here, just for bars in bar, do this. You have HA center, VA bottom, So that's also what we have here. The center, that is the bars will be in the center, and the stuff will be under our values. Where is the, I'm trying to look at where the code is here. Okay, and this one, for the next one now, we are plotting a line chart. This is how a line chart is being plotted. We picked our what? Our X and what? Y. But for line plots, we need what we call a marker. This is a marker. Or you can decide to use plus. You can decide to use asterisk. So you can see, because we are using O marker here, that's why we are seeing O marker here. You can see them here. Then the line width you want. Then now you are seeing plot.x label. But in the other one, you'll be seeing axis O as 1 because we are having two plots. So you can see the title, which is here. Do you want grid? This grid now, we are having true here, and this is the grid. And you show your what? Your plot. That is exactly what we did here. That is exactly what we have here. Grid, the line style. That line style means our grid will be like broken lines. It won't be normal straight line. Can you see the broken lines that we have here? Let me see if I can print this image in new tab. Can you see our grid now? You can see the grid is broken lines. All these ones are just styles to make your work neat. You might decide not to add all this complexity there and you get your work done. Can you see the colors now? We picked all this one automatically. I can decide to assign the colors myself. And you can see the value. Now, I was saying that part because it's AI is what has enhanced the code there. I can decide to still write it very simple, just like what I have in this data visualization code I wrote. So just for simplicity, once you are able to get the basic knowledge, the understanding, you can now decide to add some complexity to your work. Let me try and do that. I'll remove some things there and you check. And you check the code. If you still get the same thing, feed. Let me copy all this here. Up to here. Control C. So I don't want it to overwrite the one that has been there. I will label it A1, 1 here. So now plot this. You can see subplots 1 and 2, all those parts. Now I'll remove this ascending here. These sort values. I'll remove it and see. So this one is just majorly what we need there. You can add comment to it to explain what you are doing. Colors. So I also have this revenue region colors equals to this. But now I'll give it colors myself. Let me comment this one out. Sorry. Oh, I've forgotten what I did here. I wanted to comment. I thought I was programming in C++. I've forgotten this is Python. I don't know if you are familiar with various programming language. We have different ways to comment things out. So that's why I was using // So now, I don't know if Victoria, if you are still there with us getting what we are doing. I just want to reduce the complexity. I just want to reduce the complexity of what we have there and make it simple. Yeah. So now this color now, let me copy the colors I have here. You can see I defined a color for it. And luckily for us, we are just having 4 regions because I know the numbers of region we have. That is where I'll give it my own color. But using this one they gave us here would have been the best. Why? Because in cases where you might have like 10 regions, 20 regions, you have to be defining the colors one by one. It's not professional enough. So you need something that will be able to do that for you automatically. Just check colors for you. That is why this is important. But assuming it's something that is not much, you can decide to give it the colors you want. Or there are some areas you want to make them color specific. So you can decide to do that. Then the axis, total revenue per region, all these ones we are setting, the title, the X label, Y label. Then for this, The font size, you can decide to change it if you want. If not, you are good. Then I think I've removed some things here. For year two, I want to remove, okay, we have markers, monthly average index. Now, for our y-axis, it's asking us to do a different thing. I'll check now. Our second graph, right plot, it said the average monthly revenue across region, months 1 to 12. I think that place that has 13 was an error, but I've used it to generate my stuff. It's meant to be 12 months. But just in your code, you can try to correct it to 13. Yeah, you can, if you are still working on it. So you get the average monthly revenue across all region. So for each month now, all the revenue across all region, we are adding all their revenues together. So, but we will not group the revenue by what? Months. So what is the average monthly revenue across all region? In the North region, what is the average monthly revenue they make per month? In this region, like that. So for the first month, they make this average monthly revenue, second month. So we calculate it for all the region. You know, maybe North region will make $200, maybe East region make $500. So in a month, you know, they're having different revenues for a month. We can now calculate the average, add the revenue of North region, West region, East region, and South region. Add it together and divide it by 4. You get the average. So that is just what they ask us to do, which is what we have here. Monthly average revenue. You define a group each month the revenue by month. Then you find the mean of it. Hope you can see it. Just very simple. You find the mean, then you plot the graph. Here we have a marker style, and we have marker and the line style. They are even giving it a line style. We gave it a color. But here I can decide that I didn't want blue. I want green. You can give it anything. You can modify all these ones. So, and then if you are into data analysis, all this time when you are creating plot, there are some tips you follow. If you check the slide that was sent, you can go over it. You see some tips there. There are some tips you follow, because everything is not just about how fine your work is. No, it must be consistent, it must be readable, and all that. You see that in the part of the task that was given. I think part B or so. You see that also there. So now we have this set, title, label, all this. But now for the grid, true, I don't want the line style. I can remove it. I don't want. And you see that it will still work. Then print tight layout, because we're having 2 plots. That's why the complexity is a lot like this. And all this now, for someone into graphics, it's just tells us how clear you want this to be. I think I don't know the highest DPI we have, but because I do graphics, it's mostly between 0 to 300. That is the one I'm not familiar. I don't know if we have higher DPI more than 300. But now 150 is just like the middle point. Like for media, if you are using your screen system, screen, phone screen, most time they use DPI of 75, 80, 100. And I think even people, if you are Alex, that's into web development, you people use DPI. I don't know. You people use something like DPI in web development.
We use pixels.
Pixels. Okay.
Yes.
I think it's manipulated. So it shows how clear the stuff, because sometimes you can make, if you use a lower DPI now, for example, and you do it on your screen, is okay. Now taking it to another, is maybe a wide screen, a bigger screen now. Something of that you created, that plot you created, might not be clear again, might be looking graining, just like the way we have movies, where you see different qualities. So that is just the way DPI works. Sorry. So that is just the way DPI works. So that is why you need, at least you need to use a higher DPI and not too high too. So you need to use a higher DPI. So I will show it. So let me try and run this one. So it's trying to run. You can see that I removed some things here. and it's still working. You can see I change this one to green. Let me open it in another tab. And this one I gave it color, but the color I gave it is not really that fine, but I defined it my own. You see that I simplified this and I still got the same result. So it depends on how hello, I don't know if you can still hear me, let me know. My network
Yes, I
went
can
off.
hear you.
And I hope you can see my screen.
Yes, but it's showing your call is in another window.
Okay, yeah, I just want to confirm that.
All right.
Yeah, I can see the one that was created now. No, is this not mine? Okay, this. I think this is the first one because I'm seeing some green. I've changed my own color. Yes, this one we edit now. You can see it's almost the same thing, and we did different thing. Just change some things. So you can decide not to make your work complex. The best thing is you understand what you are trying to do. Even though you say now, because maybe once we get to some higher part of the course, we will now teach how to even merge AI with our work. It will make our work easy. It will make it easy in troubleshooting. But if you don't understand the concept, the reason I don't want to be bringing it in now is if you don't understand the concept, because we can't deny the fact that AI is here and AI can write code very well. But there are sometimes AI can over complex things for you. And there are sometimes it's try to deviate from your goals, what you are trying to achieve, add unnecessary things. So if you understand the basics and some things, you'll be able to guide the AI to help you do what you want to do. And you'll also be able to write some things yourself. You know, me looking here, some of these things I said it was chosen by AI, but I still manipulated what is here, and I'm still able to get some good things, some good results here. I've even applied, especially even in web development, even though I'm not a web developer, but I can still make some website design that will be okay because what I'm able to use what AI. And if I should do it, you look at it, you even think it's done by a professional, even though you might see that, but because I understand how those things work, I can twist and manipulate it to my taste, and I'll get what I want. So now we are done with the first plot. Now the second one now says we should plot a scattered plot. So if you plot a scattered plot, sorry, give me a minute. Sorry for that. I'm trying to see if I can charge my system so that it won't cut off all. So now for the scattered plots now, scatter plot is used to show whether two variables are related. Now, I made, and I don't know for some of us that were not on the call last week, we made an example with the study hours versus exam score. That how is it hours that the students used to study? We want to carry out a research. You want to know that, does it mean that if a student spend longer hours in studying, is going to get a higher score in exam? We don't know if they are related or not. You decide to carry out a research. And one essence of data analysis also, sorry, the reason I'm talking more about data analysis, because this data visualization is applicable more to data analysts. Though those in data science also use it just to explore data sets in exploratory data analysis, EDA. That's where we use it in data science. So now they will need to visualize that, because it's not everybody that will be able to go through your data. And even from the data now, from this, let's say study and score, I can't really predict. I will now start using my eyes to see. But when you have it visually in the graph, you can predict if they are related or not. You can predict, oh, these things are in clusters or that. So that is how scattered plots look like. When you see things plot together in the same area, or from here now, this is the hour, this is their score, for example now. So now, let's say somebody here is like spending 24 hours, the last place here. And you can see that the person that spent 24 hours here is having a score very high. So we can see that there is an increase. So we can say the numbers of hours students studied is what will affect their exam score. It will show how high they will score in their exam. But assume we have someone that is in this studying the high, having a high study hours, like 24 hours, now having a score in this place, and maybe in this place, having a score here, we can say, oh, it's not related. It depends on some other factors. I hope you are getting the explanation. So back to the second part. It said plot a scattered plot with regression line. You can decide to still leave the regression line, focus more on the scatter plot now. That will plot the units sold versus revenue. So the units sold will be on x-axis and the revenue. So we want to know that, oh, unit is how many. Let's say we are selling milk, for example, and we are selling 4 cartons of milk. Selling 4 cartons of milk and the revenue we generate, like, are they correlating? Because for some products you can just sell a little, maybe just one quantity, and for some that you sell like 3 or 4 quantity of that product, the one you said one quantity will generate more revenue than one you are selling what, a higher quantity. So I don't know whether I get the analogy I'm trying to make now. So we want to see if they are related. So we plot the unit sold and the revenue. Oh, does it mean selling higher quantity of the product means higher revenue? We really want to know. So that is why we are using a scattered plot. So we'll color each point by categories. That is 4 colors. These are the instructions given in the task, 1 per product. That is, we will now add a single overall regression or trend line. This regression or trend line, you can see something here. You can see this red line is a regression line or trend line. It's showing the trend, that is going up. Also, it's going like this. So they ask us to add a line to it. Then we will add a legend that will show that legend. You know what a legend is in a graph? I don't know if you have it here. The legend are something, maybe some the upper part, it can be anywhere. Let me see. Yes, you can see what we have here is called a legend. So anywhere you have blue color is showing tablets. Anywhere you have this orange color is showing watch. Anywhere you have this green is showing what, laptop. Anywhere you have this red is showing what, phone. Can you see? This is a legend. If it's a line, can you see maybe anywhere you have broken line is this. Can you see something like this? This is also a legend. So that is what is called a legend. So we have to add a legend to it, and also the passes each 1 color per what, we have 4 colors, so each color per product, this color will differentiate this product. You can see that in the legend. So then we'll save the picture. So the legend will show which color is which product. So that is just what they ask us to do. So for that, we need to get what, the unit sold. We'll plot the graph of units sold per what, revenue. So let me check this one is what we did last week. I think scattered plots is not there. I'm not sure if it's there. Yeah. This is a good trend line. This one we are having, there is a trend line, but it's not perfect because normally it's meant to go up. It's to tell us the stuff is like, I don't know, when we have linear regression, it's going up, it's increasing, it's showing us the trend. So now, assuming we have something going straight like this and now coming down. So what does that mean? It's showing us that what the trend is what? Increasing and what? And decreasing. I hope you are getting it. But now, since we have a trend line going up, it's showing us what? It is increasing. Showing us that it is increasing. So now, we'll be checking the same thing here. So, okay, I think I wanted to show the code for that. You can see scattered plot. You have the colors. This colors is like conditions when we are defining the colors, or maybe for a product. Now, for this study hour, we said if the score of the student is greater than or equals to 70, you should use green. Or else, if the score is like maybe less than this 70, it's using what? Red. You can see less than 70 red, greater than 70 green. So that color can be based on conditions or anything. You define it, then plot your scattered plot, the hours versus score, that is x against what? Y. Our x is what? Hours, and our y is what? Score. Then we're having colors. C is equals to what? Colors. What we define here, our score now is equals to what? 100. That is the total. What is the total we have here? 100. So we put our label almost similar to bar chart and the rest. That's what you are calling, because this stuff we are using now, Matplotlib, is also a library, and I believe all of us know what a library is by now, and we know how a library functions. That is why we have to go through some basics in that place. So now you using scattered, calling pre-lt. Now you will see that you import matplotlib.pyplot as what? plt. This is an alias. So inside that library now, we're having plt. Then we're having a function there that we have what? Scattered plot, bar plot, line plot, and like that. So that's why we have this here. So we have y label, x label. All these ones are just functions inside the library. If you have time on your own, you can go through the library and check how the code was written. But it will be too long. That is because when you have all these functions, you are not even using the full things inside that library. So if you check it, you will really know how extended the library is, and that's why they update them from time to time. You see version so version so. So everything was not done at a go. They keep adding functions to it. So now let's go back to our task. So for this now we have this. Okay, this was plotted using Seaborn. It was plotted using Seaborn. But I will do this now because Seaborn can also do that. How do I know this was plotted using Seaborn? I don't know if anyone can tell me how I knew it was plotted using Seaborn. Seaborn is also a library used for plotting charts. I don't know if anyone can tell me.
Please, can you show it again?
Okay, I will show you. Okay, this is it. From here, and I have plot.figure, and I have all this. How did I know it was plotted with Seaborn?
Because of the SNX alias.
Okay.
Because of the
But the
library.
SNS, what does SNN mean? Is this telling us it's Seaborn?
And that means they've already imported it. They've already imported the library as SNA.
Yeah, that
As
you
the
are right.
abbreviation.
This is it here. Import Seaborn as SNS. Hope you can now see it.
Yes.
Yes.
Yeah, so that's how I knew it was Seaborn, because if I should see PLT, I already know it's Matplotlib. So me seeing something else, I knew it was Seaborn. So that means to show there are some of those charts you can also use Seaborn to plot. You have this data. This is the data we want to plot. Then the X is what? units sold, Y is what revenue, U is the what products, the score now. Is this score? I think total the total entries we have it now, because this one is now a table. We have what 80. How far is this? This is the some other informations. I think the regression line plots, because we are adding a regression line. So the thing I will also do here now, I'll now plot this using Matplotlib. So from here now, the trend, you can show that maybe the unit sold, you can't really deduce much from here, because for some of the products, we are having phone. This red means phone, right? So now when we have the quantity of phone is not much here, but we are generating higher revenue. Can you see part of what I'm saying? So for another part now, we're having phone. If you like sell, maybe phone is here. If you sell a higher quantity of phone, the revenue is still almost in this area. So, but let's plot it using PLC and see if what we have still be the same. So I just want to copy some parts here, so I don't have to write everything in. So this was like a combination of Seaborn and Matplotlib, because I'm seeing PLC here, but I will try and correct it all to Matplotlib. I just play my system will help us to finish. Right. So for okay, we have the plots scattered, then with hours and the what and the score. We define our colors. Okay, let me just use this. I'll call this and exchange it back onto C. So we have here now. I'll still comment Seaborn out. So scatter now. Here you can see that our data now is the data frame we created earlier, DF. That's why we are seeing df.info, df.ed. That is our data set. Now, so let me check the previous one that have been plotted. The data set is what df. So I think I will just use that also. I'll use, let me see if this will work. df, then I will have the colon. Now, what are we plotting? Unit sold, right? Units sold. Then we have df. Sorry. So we have revenue. So then we have colors. I've not defined the colors yet. I'll do that. Then the S is what 80. So what else is in the basic things? Okay, the label. We add that the title. Yeah, okay. Let me add this here to see. Some of these things is already there. I will delete some that are not needed there. I have this already. The grid and the show. Now you can see this. Okay. Okay, let me add this here. Ctrl X. So now our own is this DF unit sold and all that up to here. Control C. I'll paste it here. I hope you are still following. We also bring this
Yes,
in.
sir.
All right. So this is Z. Yeah. So this is then DF. This is our X. Control C. I've not added the legend here, but let's still try and see if our code will work. We'll come back to the legend. Let me comment this out. So this is where our regression line, I think regression line comes from somewhere here. Let me save this as a 1. So it won't rewrite the ones we have already. Let's see if this will run and not return errors. Returning errors somewhere here. Okay. Let me use this then for them.
Okay.
Where else you need sort this? So now this is where the next error is. Okay, yeah. It's like I'll comment that page out and get our graph first. We're trying to plot this out. I want to use just only Matplotlib alone, but some errors are returning here. Okay, it's even created the plot, but the lines there. Okay, colors, use CMap. Some, okay. Okay, this colors was not defined yet. Let me just give it a random color. Or let me bring the colors here. Colors here. Yeah, okay. It has suggested for me tab. Tab, yeah. So let me run this and see. Notice still some other errors we are still having. That is one thing about code. You still be throwing errors and errors. To save time, let me try because of my battery. So while that is being done, so each other part have been done. The third part says we should plot a histogram. What is the difference in histogram and bar chart? Okay. For histogram, this shows the frequency of distribution of a variable. So now we have age now, for example. Age is being plotted here. People between this age and this age. Now we want to maybe, let's say, the average age now. How do we get the average age? We will plot a line. When we calculate the average age, we plot a line to show it. So, or some other information. So this when we mean that, okay, the average age is between this spot, 23 and what, 26. So that is just an example of what, of histogram, of how histogram works. So when you have age, salary, test score, and all that, you have any numeric data and you want to show how the distribution, oh, how are people distributed now? Even from here now, we can see that we have more people in this class of age, 23 to 26. We have lower people that are above 30 here. You can see. You can take some decisions from histogram. It shows distribution. So that is the graph for the next one now. So for that, where is the code for it? Sorry. So the code for the distribution, probably I will still share this place, though you might have some errors being thrown there. This is the graph for that. You calculate the mean. You rate the stuff says draw a vertical dashed line at the mean rating. We need to rate the product also. Plot a histogram of the rating columns. Yeah, in our columns, you can see we have rating here. That is, we are rating each line. Oh, 3.5. We gave a rating for it. And how was the rating calculated? The rating was chosen randomly also. So now we'll plot the distribution showing the rating. Draw a vertical line that will show the mean rating, the median rating. Median rating means the middle rating. The mean rating is the average rating that most products are having or most regions are having. Maybe 2 is the average rating, but meanwhile, the median rating, the middle point is maybe 4, for example. So that is just what we have to do, and you add a legend to it. So this is a graph for that. This is the rating. We have the frequency means these are how frequent are those rating coming up. You know, we have 8 entries or so. So now when we those with 2.5 rating now, we have them coming very often. Those between 2.5, those in 3.0, you can see this should be 3.0. You can see the frequency. Then those the middle point of rating now, the median is what, 3.5. This is 3.5. That is the median. So, and the mean rating is what, 3.58. So that is the average rating most products are having is what, 3.58. Meanwhile, the median point is what, 3.5. This just shows distribution. That is what histogram does. It shows distribution. So let me accept and run this and we'll check the stuff back. So this is still using Seaborn. So now let me give it the command. Use purely Matplotlib library. Matplotlib library for the code for the scattered plot. There's also what we call, maybe we'll still take a part where we talk on prompt engineering, so how you prompt your work. But this one is something, there are ways you prompt it to get the results. So I think we've done the first part of the task, which is part A. So I don't know if you have any questions before I move to the part B and C. Those ones are very simple. I might not even, I'll just explain those ones. Do you have any question? Hello? Okay, no question. What of Precious and Victoria? Any question?
No, I don't have any question.
Okay. So, okay, this one is still running. You can see it as try plotting it using what? Using Matplotlib alone. That is the prompting I gave it. So it has to get each product and the color map. That was the issue. I think color was part of the thing I've been giving issues. So it has to get a color map for each product. Can you see? Each product unique. This unique means, in the product, if you have 10 products, it will get for each of them. Each of them. So that is what unique means. Then it's generated a color for it from the color maps. Then for I, that is each product in the product, you need to plot a scattered plot for them. Unit sold. So this is like a loop, a for loop. So let me check the Seaborn part and see how that eliminate that, because now our code is using just only Matplotlib there. So okay, line quest, there is no for loop here, but it was able to plot because Seaborn, the way each libraries are written is different. So for each product now, it has to plot the scatter plot for each product based on the colors. In the other part that we have color here now, the reason why this one was simple to plot is we gave a condition for the color. If the S is between this, give this color. If is this, give this color. That is why it was very simple. But for here now, for each product now, we are giving them a color and their sales. We are not giving maybe a condition for it. If they are less than this, no. We are actually giving the colors based on products. So if the product is having a lower revenue, it doesn't concern us. But since it's a particular product, give it a particular color. That's just what we want. And you can see what we have here. Tablet, watch, laptop, phone, and regression line. This is the regression line. From the regression line here now, what can you say from this regression line? I want to know if you understand what we've been explaining. The regression line just will give us, because looking at this plot now, you might be unable to make decision with it. It just like everything is scattered here and there. But this regression line will do some calculation. We have for in data science, part of the methods for predicting is linear regression, which is used for predicting something that is linear, the relationship. So now this regression is trying to tell us the relationship we have. So normally you can see that the unit sold is increasing, and on the norms is our revenue is meant to be increasing based on the unit sold, right? Let me get a thumbs up from all of us if you are getting it. So now, but from what we are seeing here now, we are seeing that it's like this trend line is going down, right? But it did not really go down very well. Assuming it goes down like this, goes down very well, we'll actually know that the unit sold does not reflect the revenue. But at least even with the little going down that we can see that it doesn't matter whether you are selling 50 units of a product. It doesn't matter how it doesn't reflect on the revenue generated. The revenue generated is based on what? On each product, because some product cost higher than some other products. You can see the product that is having higher is phone. And you can see here now, the reason why the graph might not look the same is because we have different colors for it. You can see here now that you have 2 red here, which is phone. You have 3 here, which is phone. But here we are using blue for our phone. In the other plot, you see the same thing there. You can see these 3 here, 1, 2, 3, and you can see these 2. It's still the same graph is generated for us, just that the colors was different. So now, phone now, it doesn't matter. If you sell lower number of phones, you still generate a higher revenue. It doesn't matter. So it's the unit sold and the revenue. Yes, they are related, but it doesn't really influence the revenue generated. There are some other factors that influences the revenue generated. So that is also what the regression line is trying to explain to us. So, okay, let's check compared to the first one we generated. You also see, you can even see from the regression line here now, that is what is also slightly coming down. You can see that because you can see this watch, for example. Now you have watch here, You have watch here, you have watch here, you have watch here, watch here, watch here. So there are some other factors that is influencing this thing. So not just the unit sold. That is just the simple information we can derive from it. If you give it to a data analyst, he will analyze it very well for you. And I don't know, for people that might be interested in data analysis, we have a course, though we've not started the class yet, but registration is still on. You can have it. Our one of the instructors there is the expert data analyst, and they will be able to teach you how to get information from all this, and you create a dashboard, you extract informations. Yeah, so part C of part B rather. Okay, let me go to the main. What part B and part C is I was saying the other time that as someone into maybe analyzing data, I don't want to be using data analysis too much, whether in data science or data analysis. You don't just use colors anyhow. You don't just use things. You can still be using grid line in some plots. The reason now, especially when you are working with line plots, if you are using bar charts, I believe by now you should be able to know the difference between all these basic charts. We have more than that. But line plot, scattered plot, histogram, and which one again is 4. Line plots, scattered plot, histogram, and bar charts. Yeah. So for bar charts now, all those ones they don't need grid line. But when you are working with line plots, you will need grid lines. Grid lines, and which other ones requires grid line? I think scatter, I'm not sure. So grid line is really needed for line plot. It will help your user to be able to trace those values even without having to get a ruler. All those things, there are some things you need to consider. So there are some tips, there are some colors you don't really use. Most times now, the way we are using dark mode here, if you are creating a plot or a graph for others to see, not for your own personal self, it's not advisable you use a dark background. There are some things. So unless it's just for yourself or some set of people, or maybe you are doing it for developers. When I mean developers, those that are into real programming, they prefer more of all these dark backgrounds. But if you are taking it into the professional space there to management, people that will take decisions, you don't go there and maybe on your screen and start showing them your chart with dark background. Those are some things you consider. So this part B now, you critique a chart that was created. Imagine a colleague produced a bar chart of a monthly revenue, but it has some issues. No axis label. I won't really answer this part. I'll just explain how we will do it. No axis label or chart title. That is, the first thing is, we have the x-axis and y-axis. It didn't put label. So someone did not even know whether the label, this one is for products, this one is for sales. We don't even know what the chart is doing, and doesn't even have a chart title again. One thing is, assuming your chart is not having an axis label, x and y axis label is not having the label, at least it should have a chart title. Maybe if you're saying a graph of product against sales, I will know that, oh, product is x-axis, sales is what? Or I will know this is what the graph is talking about. But you don't have a chart title, you don't even have an axis label. You might decide not to have a chart title, that is not compulsory, but at least you should have an axis label. This is what is in this axis, this is what's here. But it's not having any of it at all. The second one, all the bars, they are the same gray color, no difference. All of them are having the same gray color. And the products might have different type of color. At least you should have used some color. We don't know if there's an issue or not. The third one is the y-axis start at 2000 instead of 0, exaggerating the differences. I don't know whether we've seen some graph like that. It depends. There are some cases like that now. I'm trying to go to a graph here now. You can see this part now is starting at 0, right? 0 to 10,000 to 20,000. Let me see a thumbs up if you can see that, just to know. 0 to 10,000 to 20,000, like that. There are some times that you can decide to start from, if you can put this at 10,000, and 10,000 from here instead of 0. There are some cases like that, but it's not really advisable. At least you start from 0. You cannot change your scale, maybe to accommodate whatever you want to show, but it's best to start from 0. There is a reason for that. So if you know that you don't have more values down, you can have some graph that all your values will start reading from what, maybe for 30,000. So now you from 0 to 20,000 in your plot might just be useless. Also there are ways to overcome all that, but the person did not even start from 0. So the person did, so you reading it, you don't know if those graphs are equally spaced now, and if it's in 9 plots, you might not be able to really trace, oh, is this stuff correlating, is it showing the real differences there? That is one of the issue that was noted on the graph. I need to round up before my system goes off. Then there is no grid line. You know, I made an example, but note this chart is a what? It's a bar chart. Keep that in mind. There are some things that might be an issue for bar charts and might not be an issue for line charts and line plots. There are some things that is an issue for line plot and it's not an issue in bar charts. Note that. So there is no grid line, so it makes it hard to read the exact value. You know, I said this the other time. The font size is 6 points. For even those of you, if you are used to Microsoft Word, when you type some word, if you put it in 24 points and 11 points and 6 and like that. So the font size is 6, making it barely readable on standard screen. Even these instructions is giving us an hint. So for each of these issues, you write, why is this issues that was said here? Why is it a problem? I already said this axis label. I already give an example. Because axis label or chart type, so if there is none of this, the person reading the graph will not be able to know what the graph is about. So you write in the B1 issues, because we have 5 issues here, the problem inside in where you have your answers here, you put it, this is why it's an issue, this and this. Then what should be the solution? Oh, the person should add an axis label, the person should add a chart title, or at least the person should have this. You put your answers here. You do it for the 5 of them. This is just for you to know whether you know some tips you need to follow. You can check the slide that I was given in the last class to check. So you do for all the issues, there are 5 here. Then this part is just to print it out. Oh, for issues 1, this is why it's an issue, and we'll now compare it. Okay, this is why it's an issue, this is why it's an issue. So we'll compare it with our what? Our answer. Okay, this is how to fix it and all that. So that is what part B is about. I don't know if you are clear on that. The major part is part A, which we've all done the review together. While for the part C, this is talking about tool selection. And I think I explained how we select tools here, because you need to know what each tools is about. Histogram has its own purpose, scatter plot, this is its own purpose, line plot, and all that. So now, for now, you want to show a kind of regression or trend. Yeah, when you want to show trend or changes over time, use line plot. If you want to show trend and you are going to use histogram, it's not relating. That trend you want to show, people will really see the trend. If you want to show how related products are, is there any relationship, and you are going to use line plots. So those are the things you need to know when to use them for each scenario. Now this one is saying choose either Matplotlib or Seaborn. There are also some scenarios where the library too, because each library now, you can study more about each library. What are the kind of charts you can get from Matplotlib? What are the kind of charts you can get from Seaborn also? So a data scientist need a quick correlation heat map. Hope you are seeing this. It needs a heat map. Now, if you go to the slide, this slide will really help, because it shows some things now. All this stuff now, line plot is done with Matplotlib, bar charts, Matplotlib, scattered plot. All this is telling us this place. You see the purpose in summary, and it will explain it here. It's this one is telling us the tools. This one talks more, all that, and even some sample codes are here. So this slide is important to help you answer the question. So Boss Plus uses Seaborn, its map uses Seaborn. So the tool that the person will be using here, you select, oh, is Seaborn. You put it into this place, Seaborn. Then the reason is because then that's I said you now read on those library. This library is good for this and this and that. This one, a multi-panel chart, corporate color, and sometimes a chart like example now that we saw scattered plots, you can use Seaborn and Matplotlib, right? So, but there might be a specific reason why you prefer one than the rest. You can see when we wanted to use Matplotlib, we had to use for loop, but when we use Seaborn, we didn't use for loop. But what we now did is we mixed Seaborn and Matplotlib together. Seaborn make the work simple. They will now use Matplotlib with it. Those are things is the two you can use. You use one here. This is the reason. You put the reason and the two here. So that is just what this part C is about. So after we are done with that one, then it will print task complete and all that. So what we just need is then the code you wrote to answer, which you upload to your GitHub. Then because you'll be uploading it, some people might decide to use the Python notebook. You can see all this format. If you are using the Python notebook, it will show the results. As you can see, once I download it, will show all this graph. But if you are using a Python file, it won't show the results. It will just show the code. So in that kind of scenario now, you might still need to upload, even though you are using Python notebook. You can see in a place that we wrote A1 saved, it's saving all those pictures. If you check all these places here, you see print A1 saved. Save this one as PNG, save figure. And this, you can check your runtime. If it's VS Code you are using, it will save it to the folder you are working in. So you can get the picture from the folder in VS Code. But if you are working with Jupyter Notebook or anything, you check your file section, then you can see the graphs here, A1 revenue, A2, A2, A3. So you just download them here and you upload them together to your what? To your GitHub together with the code. Hope you are getting it. So that is just the explanation for this task. It's not really complex because this is just even, but at least if you can do this and you understand it, the basic thing here I'm insisting on is understanding. Understanding will help you do a lot of things. So if you are able to do it and you really understand it, so it will help you. And then by the time you move to more complex work and all that, we should have started on we wanted to dive into data science where we would work on AI and machine learning, but more of machine learning. But before we go there, we still need to you need to know this. We will now go to some libraries we use and some EDAs before we now start creating models. Even data analysts create models, predictive model. All these decisions you are making, they can create a model to at least generate the result and analyze it. All that a model will do that for them. So by the data now, based on this information, they can now say, okay, predict in the next few months what is the sales of this region going to be like. That is where predictive model comes in place. It's an aspect of data analysis and more of data science too. So we'll be diving more into it in subsequent time also, but information about that will be passed. So, but at least let us get all this and be on the same page then before we can move forward. So I don't know if you have any question. Is there any question or are we all clear with what we've done today? Hello? Hello, can we still hear me?